Welcome back, I'm that Chemist, and today we have an extreme chempilation involving lab fires and some sub-zero safety practices that involve an amount of intellect which is also sub-zero. But first, a message from our sponsor. Hey there, are you tired of dealing with online restrictions and worrying about your privacy? Well, I've got some exciting news for you. Introducing Atlas VPN. Atlas VPN was created to make the internet accessible and secure for everyone. And guess what? It currently has more than 6 million users worldwide. That's a testament to its effectiveness. Just like myelin sheath cells protect and enhance the transmission of signals along our neurons, Atlas VPN shields your data, ensuring it travels safely through the vast online network. Worried about your sensitive information being intercepted? Atlas VPN acts like GABA, inhibiting unwanted access to your private data. It keeps your online activities concealed, just like the synaptic cleft between neurons. As a neurotransmitter aficionado, I love exploring vast realms of information, and with Atlas VPN, I can access a wealth of knowledge unrestricted by geographical boundaries. It's like having a synaptic connection to the world's information hub. For a limited time, you can experience the neurotransmitter-like powers of Atlas VPN Premium for just $183 per month. That's a synaptically charged offer you won't find anywhere else. And with a 30-day money-back guarantee, this is a no-brainer. Protect your synaptic pathways of data transmission and experience the wonders of Atlas VPN for this incredibly low price. Activate your neurons and click that link to embark on an extraordinary journey with Atlas VPN. I want to thank Atlas VPN for their support of this channel. Our lab uses what is called a cryocool for some of our longer running reactions that require minus 78 degrees Celsius, where a metal tube has cold liquid running through it to keep a bath of solvent at minus 78 degrees Celsius. A few years ago, our senior lab member at the time was quenching a reaction that had been running in the cryocool. She turned off the stirring and moved on to work up her reaction. It wasn't until several minutes later and a horrible smell wafting through the entire lab space, we all knew something was wrong. After some sniffing out the problem, we walked into our half lab where the cryocool is, and smoke and vapor were coming from the doer on the stir plate. It turns out the stirring she turned off was not the stirring, but the heat, and she didn't turn it off. Oh no, she turned it to as high as it would go. She melted the bottom of a doer to the stir plate. To this day, we keep this stir plate around to remind ourselves two things. One, no one is immune to mistakes, which is a bit surprising given that she was a postdoc. And two, even though you've done something hundreds of times, you still need to pay attention. So a doer is meant to keep things cold. It's like a vacuum flask that insulates stuff. And because she turned on the heating instead of the stirring, it just completely melted the bottom of it right onto the stir plate. So yeah, that's great. That's not going to come off with acetone, that's for sure. I had a strange childhood, and the household and shed chemicals were free for me to access right from the age of around 4. Me, being born the STEM 5-year-old child, asked my dad to get me information about these things before I used them. At 5, I froze a few things I found to see which ones did freeze below 20 degrees Celsius. Unfortunately, I wasn't versed in how freezers can die if you try to freeze bleach. I'm not sure how I'm alive today, given my other stories like runaway chlorine gas in my dad's back garden, and the thing that went boom, and the times I gassed myself otherwise, and my Fumigate My Flat for Mold Issues project to save the 1,000 pounds they charge. The last one went well, actually. Now, I wonder why I have asthma. But I'm not visually impaired now because of chemistry. I can blame involuntary neurology on that at least. Maybe it isn't a good idea to let 5-year-olds freeze bleach. This just further highlights why good supervision is needed when doing chemistry. If someone's not an expert, they can make mistakes and do stuff that they don't even realize is putting them in harm's way, like getting asthma. I recently discovered your videos, and while I'm not a chemist, I do have a couple of stories involving chemicals in my line of work that I would like to share. I have been an IT pro for almost a decade, mostly working in the chemical industry, and it's amazing seeing how many chemical engineers seem to forget that everyday objects are still chemicals that need to be handled properly. We had a toner spill at one of our chemical plants. If you're not aware, laser printer toner is a fine powder made from a mixture of metals and dyes. It is carcinogenic and highly flammable in its powdered form. One of the chemical engineers at the plant where this happened decided that it would be a good idea to grab a vacuum cleaner out of the nearby supply closet and cleaned up the mess himself rather than report it. This was a terrible idea, as normal vacuum cleaners make a lot of static electricity, in this case enough to ignite the now airborne toner and cause the vacuum cleaner to explode, setting our break room on fire. Oh my gosh. Luckily, he was wearing fire retardant clothing that is required for the manufacturing areas at this plant, and escaped with only missing eyebrows, and the fire was put out quickly before anyone else was harmed. Moral of the story is, if you don't know what the cleanup procedure is for a chemical, ask for help. And if you get toner on your skin, wash it off. That stuff is nasty. I still firmly believe that any chemical container should be labeled with its hazards, as well as its chemical composition, because You might assume that people know the inherent risks with it, but that's not likely the case, and somebody can always have their first exposure to a new chemical and not know what it is or what it does. I've heard of these types of fires happening before in like grain silos, or where like flour could start a fire, or even like sugar started a fire a few times. But I haven't heard of it with paint toner before, so it's very fortunate that he was wearing fire retardant clothing, but his eyebrows unfortunately were not fire retardant. It ain't stupid if it works. Filtering hot caustic through a face mask. I can't wait to see this one. Let's go. This is a creative strategy that I haven't seen employed in any of the labs that I've worked in, but it appears to be promising, so maybe we'll see more people doing face mask filtrations moving forward. In my first year of undergrad, I joined the rocketry team at my school. Now, our school is pretty large, and we had a fairly large rocketry team as well. I was a member of the propulsion sub-team, and one of the tasks we were responsible for was casting the fuel grains for our hybrid rocket engine. As a part of this process, we had to machine down these casings cast from phenolic resin. Well, one day when I was preparing a casing for a grain cast, I noticed that the form we used to prep the casing for the HTPB was slightly oversized and wouldn't fit inside the casing. I decided it would be a good idea to try and sand down the inside of the casing by hand, with no safety glasses or respirator. To this day, I still have a persistent cough that occasionally flares up due to the phenolic dust I inhaled. Moral of the story, don't work with phenolics if you're creating fine particulate matter. If you're wondering what HTPB stands for, it stands for hydroxyl terminated polybutadiene. I didn't know that phenolics have this sort of hazard, but anytime I see plastic particles going anywhere, I wonder about the environment, as well as the environment inside the lungs of people who are doing that. So yeah, maybe don't make plastic powder get everywhere, and maybe also don't breathe in that plastic powder, because that seems like probably not a good thing to do, and it seems like Xavier would also attest to this. Do not breathe in plastic powder, please. 1993 or 1994, I was an upperclassman TA in second year organic chemistry lab. Someone poured diethyl ether down the sink at one end of the lab. Another student at the complete other end of the lab threw a just blown out match down the drain. Foomp! There it was. Blue flame shooting up out of every drain in the entire lab. That is pretty scary. I have two questions. One, why is ether going down the sink? And two, why is a match going down the sink? Neither of those things should be down there. One time I had this base bath that I was adding more methanol to, as well as more base to, but I didn't let all the base dissolve first. So when I added all of the methanol to this already existing base bath, there was a slight clink of the glassware, and somehow a spark formed, and the whole methanol base bath was like, foomp, and there was this giant wall of blue flames. I didn't have a typical base bath at this point in time. This wasn't like a small bucket. This was like a big tray, and the flames that came off of this were massive. Fortunately, I just chucked the lid back on the container, and the fire went out because it was suffocated. But yikes, spontaneous combustion is very scary, and I would have liked to see what it was like in the lab where this happened. So a while back, I needed a strong acid for a buffer solution. I went to the vented safety cabinet, and as I was reaching in, I noticed the orange coating of the shelf the reagents were sitting on had partially liquefied. Further investigation led me to a suspicious canister labeled as acid waste, which didn't seem to be in the best shape. The creaking sound it made when I carefully poked it confirmed my suspicion. The canister contained maybe 15 liters of an, as of yet, unidentified mystery liquid. Now here comes the part that makes me cringe in retrospect. After informing my coworkers of the situation, one of our postdocs decided it would be a smart idea to pick up the canister of questionable integrity and lift it up onto a cart so that we could transport it into an adjacent fume hood. I felt a little uneasy watching him move it. Once it was in the hood, we unscrewed the cap and were greeted by a little cloud of orange vapor. At this point, it dawned on us that the 15 or so liters of mystery liquid inside were in fact very concentrated nitric acid. Oh my goodness. We contacted our local specialist for chemical hazard waste, and his first reaction was to pull out a camera to snap a quick picture for his next seminar as a drastic example of what not to do in a situation like this. After inspecting the canister, he told us we were really lucky to be unscathed as it had started to fail along the seam and could have easily ruptured upon being picked up. It was also nearly a decade beyond the maximum allowed storage period for this type of container. Moral of the story, check the less frequented areas of your chemical storage places, and should you find something iffy, don't move it if you cannot trust the container anymore. Pics related. So here are their pictures of it. You can see this is the orange residue that had fallen out, and this is the compromised container that had all of this concentrated nitric acid. The brown cloud that was coming out was nitrogen dioxide, and it's pretty scary to see that this much nitric acid is in a secondary container with this short of a lip. If this whole thing were to leak, it would just overflow the secondary container, so I think the secondary container may need a tertiary container. This is a really sketchy story, and you should not copy what this person did ever in any way, shape, or form. This person froze some concentrated ammonia and then they added it to bleach. This is a terrible, terrible idea. Please do not mix bleach and ammonia, and don't mix other cleaning products unless you know that it's safe to do so. This is the least safe thing to do. Do not do this. As for my accidents, you may not even believe some of it. One of the best ones is, when I managed to chlorinate our whole corridor, chlorine was leaking from the apparatus, and somehow fume hood deposited it inside the building instead of outside. Other than that, I had multiple fires and explosions. My student had a valve failure, which led to a 200 atmospheres of pressure line with carbon monoxide being vented into the lab. Oh my gosh! 200 milliliters of phosphoryl chloride going off volcano style from the condenser directly into the oil bath below. Thermostat failure. I was not deterred. Currently, I am the PI of a medium-sized research group. Geez, those are all very spooky things that you would not want to have happen in your lab once, let alone all of them in the same lab. Bit of a long one, but story time of how I mildly acid gassed an apartment. One of my friends was trying to infuse isopropanol with hydrochloric acid. However, he forgot to dispose of this experiment before leaving for Europe, and informed our other friend to not touch it as it was super dangerous. The setup was as follows: 2 small jars, one filled with HCl, one filled with isopropanol, inside of a large jar with sulfuric acid at the bottom. The issue is that if the hydrochloric acid and the sulfuric acid come in contact, it'll produce an HCl cloud. This is just because the sulfuric acid can dry out the hydrochloric acid and make HCl gas. I was the only other chemist in the friend group, so I offered to take care of it. My plan was to neutralize all of the acid, then dump it down the drain. I had created both a sodium bicarbonate solution and a sodium hydroxide solution and got to work neutralizing it, having to go slow as the reaction was super exothermic, and I didn't want to have glass shatter from being too hot. This neutralization was also done in a poorly lit, poorly ventilated boiler room, and the only gloves I had were those polyethylene gloves used for food prep. Gas was coming off the reaction that should have just been carbon dioxide, but since the sulfuric acid was impure, I have no clue if there was anything else being produced since the room started to smell peculiar. 3/4 of the way through the neutralization, I accidentally added too much sodium bicarbonate to the hydrochloric acid jar, and it started to bubble over into the sulfuric acid. I immediately placed my hand over the jar, ran to the bathroom, and turned the bath on to dilute the acid while pouring it down the drain. This is so scary, oh my gosh. At this point I can tell HCl gas is being formed because my throat started stinging when I breathed. I set up a fan to face the bathroom to circulate air out. Apparently this also made the hallway outside of the apartment smell like acid gas. Jeez. This was a pic of the setup. The brown liquid on the bottom is sulfuric acid, and the liquid on top was neutralized acid. If anyone knows why they separated and did not mix, I would be happy to hear. Those should mix. I don't know why those didn't mix. Maybe it was so viscous that it just didn't mix yet, but that is very scary. Please do not leave jar chemistry for your roommates to deal with, especially if it's dangerous like this. You have to finish before you leave. You cannot just leave stuff like this. This is the scariest thing about home chem. People who leave stuff like this unattended. I work as a public horticulture educator, which means I'm basically going out into the community answering people's questions about plants. I don't deal a ton with chemistry, but this story is an exception. I was called out to this one house to identify a weed that was growing on a dirt pile, and when I got there, I could instantly tell it was in the carrot family, thanks to the flower shape. Unfortunately, I didn't have the time to identify it in the field, so I grabbed the plant ungloved and brought it with me to identify later. As I'm driving home with the mystery plant in the back of my truck, I suddenly get an excruciating pain in my right arm, so bad that I had to pull off the road. My hand had broken out in a rash, but instead of itching, it physically hurt and covered my right hand top to bottom. I decided identifying this plant couldn't wait anymore, and after a little bit of digging, I discovered, much to my dismay, that it was poison hemlock, aka the most toxic plant in the Western Hemisphere. And I had just given myself a topical dose of conine. Human bodies do not like conine. One call to poison control later, I learned that topical exposure to conine is not life-threatening, but I was not going to have fun the next couple of days. Luckily, all it took was a few non-steroidal anti-inflammatories to do away with most of the pain. But I don't think I need to tell you that I am now very good at identifying poison hemlock. PPE, it's not just for chemists. Plants make a lot of dangerous chemicals, and poison hemlock is one of the spookier ones. This is giant hogweed, and this is the one behind phytophotodermatitis. The specific chemicals are bergaptin and methoxysaline. These are the specific chemicals that were in giant hogweed that cause phytophotodermatitis. Methoxysaline is a prescription drug, and both of these are psoralen derivatives. Psoralen is used to treat psoriasis and eczema by essentially burning the skin off after exposure to UV. The issue with periodic acid, is it only works every other day. Finally, I'd like to thank everybody who supports the channel on Patreon. If you want your name mentioned at the end of Extreme Chempilations, you can support the channel at patreon.com/thatchemist. I hope you've enjoyed, thanks for watching, and I hope you have a great day.